All right, now that we understand how to find the vertex of a quadratic equation, let's take a look at a real-life application. Here's the problem. The Kane family went to Bermuda on vacation. While they were there, they found a replica pirate ship with a plank. They could take a 20-foot plunge into the ocean. Sounds fun. Jude did want to jump. So he approached the plank, but he kind of froze. He froze because you're looking down at a great height, you may hesitate a little bit. Suddenly his daddy, though, snuck up behind him and launched Jude into the air. So the function that models how high he was thrown in the air is negative 16t squared plus 32t plus h of o. Now, a couple of things about this equation, okay? This is a quadratic equation, and how we know? Because the degree here is 2. That makes it a quadratic equation, okay? Also, a couple other things. We understand now that if you look at the leading coefficient, it's negative. So if you remember from the other videos, we have a parabola that opens upside down. All right, so the variable here, t, that represents time in seconds. All right, and that's going to tell us how long it takes. And then this h of o that you're seeing here, that's your initial height. So that's how high Jude was off the ground before he was thrown, which is embedded in the problem. All right, so let's take a second to see what's going on here. And I want you guys to know and remind you that I can't draw, but I'll do it anyway. So here we go. Here's the water. Here's our little pirate ship going on. This is my pirate ship. Do not judge. Here's the plank, okay? Here's Jude. Here's Jude hanging out, loving life, okay? He's seeing the water. He's thinking about jumping in, but he's hesitating. All of a sudden, there's his dad, okay? And he throws him high in the air. And eventually what's going to happen is gravity's going to take over and it's going to pull him to the water where he goes crashing into the water. All right, so what we're looking for is specifically this spot right here, okay? This problem here asks 2 questions. The first question is, how long will it take him to reach this maximum point? And then what is the actual height? So to answer the first question, we need the axis of symmetry. And that's the formula we discussed before, that opposite b over 2a. So taking from this formula, it's opposite 32 over 2 times negative 16. And if we simplify this, negative 32 divided by, well, this bottom is negative 32, that gives us 1. And what does that 1 represent? 1 second. So it takes Jude 1 second to reach this point right here. Now, to find out the actual height, okay, of that spot, okay, we're going to take this in, we're going to take this number, we're going to plug it into the equation. So it's going to be negative 16, 1 squared, plus 32 times 1 plus. Now, what number goes here? I told you before that represents the initial height. In this case, if you look at the problem, it says it's a 20-foot plunge. So when Jude is standing on this diving board or this plank, he is 20 feet from the ground. So you're going to substitute 20 for h of o. Now, from here, it just becomes calculator work. So when you evaluate this in the calculator, and again, like I've always said, be careful when you're plugging in, you're going to get 36. And again, to interpret that, it's 36 feet. So here's what we have. Daddy launches Jude into the air. He's screaming. He gets to this point in 1 second, and he's 36 feet above the ground. That's a good throw by his daddy. That's a 16-foot throw. And then that's when he reaches the max point, in which case gravity plunges him into the water. Thank you.
Bye.